We're going to go through 8 really quick on page 382. This is the second video, second take, because we made a mistake on the last one. So we're just going to run through number 8 really quick. If you need to stop the video to be able to stay on track, I'm going to run through it quickly. You can pause the video as needed to slow me down, okay? So number 8, negative x plus 5y equals 13. And x minus y equals 15, okay? Your x's, as you see on here, your x's can actually be eliminated because there's a negative x and a positive x, and you would use addition to make that happen. So negative x plus x is 0. It goes away. So then you have 5y plus negative y. So 5y minus y is 4y. And then 13 plus 15 is 28. Okay? So now how do you solve for y? Divide by 4, divide by 4, y equals 7. Okay, so how do you solve for x? You substitute y back in. So x minus 7 equals 15, plus 7, x equals 22. All right, so that's number 8. Now, once again, if I went too fast for you, you're welcome to pause the video so that it slows it down for you. But we just went through it quickly because in this class, we've already done this problem. Okay? Let's move on to the next one. Back to number 10. The problem is 4x minus 7y equals 3, and x minus 7y equals negative 15. So on this time, we're not going to change the signs because that's what messed us up before. We're just going to understand that they change, okay? So to be able to eliminate, if you look at your x's and you look at your y's are not equal, but your y's are. So what sign are you going to use out in front of the equation to make it happen? It's going to be a negative sign because we need the negative 7y to turn into positive, and a minus a negative becomes positive. Same thing with the negative 15 over there at the end of the second equation. So we're going to make a negative sign. 4x minus x is what? 3x. And negative 7y minus negative 7y, minus a negative becomes positive. So negative 7y minus negative 7y is negative 7y plus 7y. That makes it totally disappear. Okay? 3 minus negative 15, that becomes positive as well. So 3 plus 15 is 18. Divided by 3 to solve for x, and x equals 6. Okay? Just like we got the last time. Now this is where we messed up because I had actually changed the signs. So let's substitute it back into the bottom equation, putting 6 for x instead of x. So 6 minus 7y equals negative 15. Minus 6, negative 7y equals negative 21. Okay? When we divide to solve for y, we divide negative 7 divided by negative 7, and y would give you positive 3. That's where we messed up last time. Do you guys understand where the reason we messed up? Because I had changed the signs in the second equation to positives, okay? And that's why we kept getting a negative. So x equals 6, y equals 3. You write it in ordered pair form, and your answer ends up looking like that. Okay? You understand? Okay, so let's go down to number 16 on your homework, page 382. You have 3x plus y. Let's get a clean screen. You've got 3x plus y equals 5, and you have 2x minus 2y equals negative 2. Okay? When you look at this equation, is there an x or is there a y that can be eliminated? No. The 3x and the 2y, those don't cancel out, and the y and the 2y, those don't cancel out. So now, that's the first question we've asked ourselves. Is there an addition or subtraction that can happen, that can take place, and eliminate one of our variables? Well, obviously the answer is no. So we go to our next question. Can we multiply one equation by a specific number to make that elimination take place? And in this circumstance, we can, okay? If you look at your x's you would have to multiply both by. But if you look at your y's, you only have to multiply one of them by, okay? So what would we need to multiply the top number by to make it the opposite, opposite of -2. We would have to multiply it by +2. So it would be +2. Okay? So multiply the whole top equation by +2. 2 times 3x is 6x. And then 2 times y is +2y. And 2 times 5 is 10. Okay? Now what what operation do we need to use? Adding or subtracting? Adding, okay? So put your plus sign over here. 2x plus 6x is 8x. And then the y's cancel out, and you're left with -2 plus 10, which happens to be 8 as well. So divide by 8. What is x? X equals 1. Okay? Now you have to substitute it back into one of the equations to get your y. I'm just gonna pick 2x minus 2y equals -2. And when I substitute that 1 in, it goes right here. So then I have 2 times 1 is 2 minus 2y equals -2. Then minus 2 minus 2. These cancel, and I'm left with -2y equals -2 minus 2, which is -4. And that would give us y equals +2. Okay, so for the sake of time, we're going to skip the one where you multiply both equations by a different number. We're going to go down to one where you have one solution, which would work out just like the ones we've done. Infinitely many solutions, which would be what? What were our 3 I's yesterday? Do you remember? Identity, identical, infinite. Okay? So if they're identical, that means that they're considered an identity. Identities mean that there are infinite solutions. Okay? Now, if it's not equal means no solution. Okay? All right, so let's go to number 22. And let's look at 3x plus 4y equals 24. And then we've got 6x plus 8y equals 24. Okay? And now when we look at this, we're going to have to multiply the top one by 2 or -2 to be able to work with these. Okay? So -2 times 3x is -6x. -2 times 4x is -8y. And then -2 times 24 is -48. Okay, so what can you notice about your two equations? If you subtract 6x from 6x, they're gone. If you subtract 8y from 8y, it's gone. So what do you have left on your left side?
24.
A 0. Okay? Now 24 minus 48, what does that leave you with on your right side?
24.
-24. Okay? So you have no variable, so it definitely can't be one solution. They're not identical, which means it's not an identity, which means it's not infinite. So what's your answer? 0 equals -24. That means no solution. Very good.